Today we discuss one important topic related to dual space. Okay, we also talk about now for a vector. Okay, x belongs to v. For a vector x belongs to v, we define. Okay, we define x cap. X cap here v star to f, v asterisk to f by x cap t equal to ft. Understood? For every, okay, sorry, x f x, okay, here x, then for every f belongs to f star v star, okay, then it is easy to verify that. Then it is easy to verify that x cap is a linear functional, is a linear functional on v star. Okay, so x cap belongs to v double star. Okay, so the correspondence, okay, so this correspondence, this one x to x cap, okay, x related to x cap allow to define isomorphism, okay, isomorphism between v and v double star, okay. Understood? Then what happened? We also talk about that v star equal to what? V star equal to L of v8, okay, that is the space of all linear functional from v to f, okay, and v double star equal to what? V double star equal to L of v star f. Understood? Then we also discuss this one, this some map, okay, x cap t equal to fx. This one be a linear functional, okay, on v star. So we now going to discuss one lemma related to that topics. We erase that portion. Here lemma, okay, let v be a finite dimensional, vector space. V be a finite dimensional vector space, and let x belongs to v. If x tilde f equal to 0 for all f belongs to v star, okay, then x equal to 0, Understood? Now we have to prove that. Here let x not equal to 0. Then what happened? We show that okay, there exists f belongs to v star. There exists a belongs to v star, okay, such that x delta f not equal to 0. Okay, if x not equal to 0, then x delta f not equal to 0. Okay, if we show this one, then obviously this implies that x not delta, x cap f equal to 0 implies x equal to 0. Okay, so we also choose an order basis. Okay, choose an order basis. Here beta equal to x1 x2 dot xn. Okay, for v such that x1 equal to x, and let f1 f2, let f1 f2 dot fn be the dual basis of beta, is the dual basis of beta. Okay, then what happened? Then f1 x1 not equal to 1 not equal to 0, and let f1 let f equal to f1. Okay, then what happened? That means f1 x1 equal to 1 not equal to 0 and f equal to f1. Then what happened? Then obviously this one x cap f, okay, is not equal to 0. This implies that. Okay, so x equal to x1, then f1 f2 fn be dual basis of beta, then f1 x1 equal to 1, then x cap f not equal to 0. Okay, then what happened? Then we also show that means x not equal to 0 implies x cap, x not equal to 0 implies x cap f not equal to 0. So x cap f equal to 0 implies x equal to 0. Okay, so easily we prove this lemma by contradiction method. Okay, that means this implies this, means this not equal to implies this not equal to. Okay, so we now want to prove one theorem. Okay, so we now write statement of this theorem. We erase that fix. This one is also too easy. We now going to discussion one theorem related to that. First we write this statement of this theorem. Okay, let V be a finite dimensional vector space and define okay, psi equal to v2 v double star by, okay, psi x equal to here x cap. Then what happened? Psi is an isomorphism. and isomorphism. Okay, now we also going to discussion one proof. Yeah, okay, first one, psi b linear. Psi b linear, then what happened? Let xy belongs to v, let xy belongs to v and c belongs to f, and c belongs to f. Okay, then for f belongs to v star, we have what? Psi of cx plus y f equal to, here f of cx plus y equal to c of fx plus fy. Okay, equal to c of x cap f plus here y cap f. Understood? Equal to c of x cap y cap f. Okay, therefore here psi of cx plus y equal to c of x cap plus y cap. Okay, then c of psi x plus psi y. Okay, then what happened? This one is the psi b linear. Okay, now we're going to prove that psi b 1 1 b, psi b 1 2 1. We have to prove this one. Okay, suppose that psi x is the zero functional, on v star. Okay, for some x belongs to v, okay, then what happened? Then x cap f equal to 0. Okay, by this lemma, by previous lemma, for every f belongs to, we erase our portion. For every f belongs to, okay, for every f belongs to v star. Okay, then what happened? Then obviously we conclude that x equal to 0. Okay, then what happened? Then we talk about that this one is by previous lemma. Okay, by previous lemma. Then we also write here, this implies that psi b 1 2 1. Okay, that means this x cap f, since x cap f is 0, implies x equal to 0. Okay, so in this way again we write that psi is an on isomorphism. Okay, psi linear and psi 1 to 1, then psi is an isomorphism. We write C here, psi is an isomorphism. that means just on to we have to prove. Okay, we know that dimension of V equal to dimension of V star, V double star. Okay, that means this one, this psi V 1 1. Okay, and V is finite dimensional, so this one happen. Since psi V 1 1 1 to 1 and VB finite dimensional. Okay, so this one happen. Then what happened? Then obviously that means we write here range of psi and this dimension, okay, equal to what? Equal to dimension of V. Okay, and obviously this equal to dimension of what? This equal to dimension of, okay, range of psi equal to dimension V and this equal to dimension of V double star. So what happened? So psi V on 2. So psi V on 2. Okay, so psi is an isomorphism. Then psi linear transformation, psi 1 1, psi 1 2. So psi V and isomorphism. Okay. Now we write related corollary. We erase that portion and going to discussion related corollary. Okay, so we discuss now one corollary. We write here corollary. Let V be a finite dimensional. Let V be a finite dimensional vector space. Okay, V be a finite dimensional vector space with dual space V star. Okay, then every order basis. Then every order basis for V star, okay, is the dual basis for some basis for V. Is the dual basis for some basis for V. Okay, then what happened? Every order basis, okay, for V star is the dual basis for some basis for V. Okay, now we write proof of that. Okay, let f1 f2 dot fn, okay, be an order basis for V star. Okay, then what happened? Then for V star there exists a dual basis. Then for V star there exists a dual basis. Okay, a dual basis here x1 cap, x2 cap dot xn cap. Okay, xn cap in V double star. Okay, in V double star, what happened here? That is, okay, there exists a dual basis, this one, that is del ij equal to, okay, xi cap fj, and then this one equal to fj xi, okay, for all I and j, okay. Thus what happened, thus f1 f2 dot fn is the dual basis of x1 x2 xn, okay. Then this one is the dual basis of x1 x2 xn. Understood? Now we also show that any finite dimensional vector space, okay, so we do this proof here, okay. Every order basis for V star is the dual basis for some basis for V, okay. That means f1 f2 fn is the dual basis of this, okay. So we now write here, that means for any finite dimensional, we erase that portion and going to further discussion of that. For any finite dimensional vector space, okay, this one, that means dual space and obviously dual of dual space are all have dimension are equal, okay. That means dimension of here V star equal to what? Dimension of LVF equal to dimension of V dimension of F equal to dimension of V, okay. Not a problem at all, okay. If V is finite dimension, then this one happen, okay. And so we write here again, that means dimension of V equal to, we show that dimension of his double star equal to dimension of LV star F, okay. Here dimension of V star and dimension of F equal to dimension of V star and equal to dimension of V, okay. So what we get, so dimension of V equal to dimension of V star equal to dimension of V double star, okay. That means dual space of V and dual space of V have dimension same if V is finite dimensional, okay. Now we discuss here if for infinite dimensional space, okay, for infinite dimensional vector space, okay, for infinite dimensional vector space, no two of V star and V double star, that means dual of V and V, okay, are isomorphic. For finite dimensional space, V isomorphic to this one, but for infinite dimensional case this one happen. Okay, so now we discuss one important topics, annihilator. Okay, we known about that. We now erase that portion and going to further discussion of that. Okay, annihilator is not of is. Okay, here is not equal to A belongs to V star such that fx equal to 0 for all x belongs to S. Understood? Then what happened? That means for any subset is of P, okay, for any subset, sorry, for every subset is of P, for every subset is of P, okay, the annihilator, that means is not be the annihilator of is. Okay, now this is not be a subspace of is not a problem at all. This one happen, sorry, subspace of V star. Okay, that means set of all linear functionals. Okay, from V to F, this one happen. And again we also discuss that if W is a subspace, okay, if W is a subspace of V, then X does not belongs to W, and then F belongs to W not, okay, that means annihilator of W such that fx not equal to 0. Understood? That means here WB is subspace of V, and X does not belongs to W. Okay, then there exists if A belongs to W naught, okay, such that fx not equal to 0. Okay, W be a subspace of V and X does not belongs to W, then there exists A belongs to this annihilator of W such that fx not equal to 0. Okay, that means A belongs to V star, that means A belongs to V star such that fx, okay, not equal to 0 when X does not belongs to W. Okay, That means F belongs to W naught means what W naught equal to in this one. This implies that, okay, F belongs to W naught implies that what if x equal to 0 for all x belongs to W. Okay, then we also shows that this one implies this. Okay, for all x belongs to W. If x not equal to W, then this one happen. Okay, so in this way we also show that this one, another one. Okay, we erase that portions and then this one. If W1 equal to W2, okay, this one, if W1 equal to W2, two subspaces of V, if and only if W1 not equal to W2 not. How this one happened? Too easily we have to prove this one. Okay, now this one, let G belongs to W1 not. Then what happened? This implies that Gx equal to 0 for all x belongs to W1. Okay, and again equal to W2, so this implies Gx equal to 0 for all x belongs to W2, and this implies G belongs to W2 not. This implies this implies this implies this. Okay, so what happened? This one equal to this one. Okay, so what happened? Okay, then these two are same. Okay, then if W1 equal to W2, then if W1 equal to W2, this implies W1 not equal to W2. Okay, again if W1 not, this one is proved. Okay, now we're going to reverse. If W1 not equal to W2 not, then how we prove this one? That means W1 equal to W2. Okay, this one is one important topics. We also see that if, that means let we talk about that. Okay, which one? Let this one. Okay, let x belongs to W1, then this implies, okay, x belongs to W1, then here g of x equal to 0 for all x belongs to W1. Okay, this implies that hold this one x belongs to W1 such that this one hold. Okay, such that we write it in full stop, not full stop, we write it properly, such that this one hold. Okay, then what happened? G belongs to W1 not and equal to W2 not implies that Gx equal to 0 for all x belongs to W2. Okay, then what happened? Then this implies that x belongs to W2. This implies W1 subset of W2. Okay, and again we also erase our portion and then we will discuss this one. What happened is here, that means here let y belongs to W2 such that this one, g of y equal to 0 for all y belongs to W2. Okay, let, then what happened? This implies that g belongs to W2 not. Again this implies that g belongs to W1 not, since W2 not equal to W1 not, This implies that gy equal to 0 for all y belongs to w1. This implies that here y belongs to w1. Okay, understood? This implies w2 subset of w1. Okay, in this way we also get here w1 equal to w2. So we prove this one. That means w1 in not w2 not implies w1 equal to w. We prove these portions also. Okay, here we prove this portion and then we prove this portion. I think this one is clear. X belongs to w1 such that this one hold. This implies that g belongs to w1 not, and this one is given, so g belongs to this one. Okay, so what happened? That means x belongs to w1, then gx equal to 0 for all x belongs to w2. This implies that x belongs to w2. Okay, not a problem at all. So w1 subset of w2 and here w2 subset of w1, and in this way we also prove this one. So today we stop here. Okay, we also, that means we stop today here. And if you get this type of videos, please subscribe my channel. If you want to give like, please click on like options, and if you have any questions, comment, suggestions, write it in comment box. So please subscribe my channel. Thank you. Okay.